So here today we will start with the 11th question. Earlier we have done till the 10th question under exercise 6.5. So here we will start with the 11th question. Okay. It is given that at x is equal to 1, the function x power 4 minus 62x squared plus ax plus 9 attains its maximum value on the interval 0, 2. Find the value of a. Okay. So here that is what is given here. So what is given here? That is, it attains its maximum value at on the interval a, 2 it is given, that is this function. So what does it mean actually here? You will have to find out the value of a. So it means that your f dash of x is equal to 0. Got it? So f dash of x is equal to 0. It means that your f dash of 1 is equal to 0, that is your x is equal to 1 you have here, no? So you get it as x is equal to 1, f dash of 1 is equal to 0. So we will see how we can find out the value of a here. You have got given f of x is equal to x power 4 minus 62x squared plus ax plus 9 is what you have here. So f of x attains its maximum at x is equal to 1. So when does it attains its maximum at x is equal to 1? Only if you can find the critical points, and only at that critical point you can find out whether it is a maximum or it is a minimum. So to find the critical point, what is the condition which has to be satisfied? F dash of x is equal to 0. So what does it mean here? Your f dash of 1 is equal to 0. That's the meaning of it. So here you will have it as f dash of x is equal to 4x cube minus 124x plus a you have. Now what is given here? F dash of 1 is equal to 0 is given. So here you will have it as 4 into 1 cube minus 124 into 1 plus a is equal to 0. So it is minus 120 plus a equal to 0. So what's the value of a you get here? A equal to 120. Got it? Yes. Now here the 13th question. Find two numbers whose sum is 24 and whose product is as large as possible. So find two numbers whose sum is said to be 24 and whose product is said to be as large as possible. Let one number be x. Okay. So here whose sum is said to be 24. So if I take it as let the other number be y. Okay. So here if you want, I'll just take it as let the other number be y in this case. So here you know that your x plus y is equal to 24 because it's clearly given what is it here? Sum of two numbers is equal to 24 you know here. So what will you get here from this? Your y is equal to 24 minus x. This is what you have here. Got it? So what is the other number you get here? The other number is nothing but 24 minus x. Now you will have to find out whose product is as large as possible. So how do I write it as product as large as possible? Means like if I want, I can write it as p of x into y. This is different here, don't confuse with that. So here we will write it as p. Okay, so here and this is x into y. So when I write it as x into y, what can you write here? It's x into 24 minus x. This is what we have here. Okay, so here it is equal to, I'll have to show that whose product is as large as possible. So as large as possible is at what point we'll have to get the maximum. This is what you'll have to do here. So I've just given a name to us as y equal to, otherwise you can just keep it as p itself, not a problem. So y equal to 24x minus x squared. Now differentiating it with respect to x, what will you get? Your dy by dx is equal to 24 minus 2x. Now when you find the second derivative, your d squared y by dx squared is equal to minus 2. So what is your minus 2 actually here? Your minus 2 is nothing but less than 0. This is what you have here. Okay. Now I'll have to find the critical points here. When I find the critical point, what will you get? Dy by dx is equal to 0. 24 minus 2x is equal to 0 and you get 2x equal to 24. So from that what will you get? Your x is equal to 12. So what do you write here? The local maximum is obtained at the number x is equal to 12. So what is the other number you get here? The other number is nothing but 24 minus 12 because you had it as 24 minus x, that's nothing but equal to 24 minus 12. So the product is maximum when the numbers are, you have two numbers there, one is nothing but x and the other one you had it as 24 minus x. You know what's the value of x here? It's 12. So the other number is what? 24 minus 12, that's nothing but equal to 12. So the product is said to be maximum when the numbers are said to be 12 and 12 here. Okay. So here now the 14th question, it's also a similar one with a slight variation. Find two positive numbers x and y such that your x plus y equal to 60 and x y cube is said to be maximum in this case. So, you have asked us to check whether x y cube is said to be maximum at what point. So, you will have to find out two positive numbers x and y. The relation given is x plus y equal to 60. So, how do I proceed in this case? Before going on to the differentiation part or the second derivative test, I must write my product either in terms of x or in terms of y. So, to write this in terms of x and y, why I am writing this in terms of x and y? Because I will have to show that this is said to be maximum. Okay. So, here in this case I will have to write it either in terms of x or y, only then I can differentiate it with respect to x and apply the second derivative test here. Okay. So, to reduce this to the x or the y term, I am going to make use of this relation x plus y equal to 60. So, what have you got? Given x plus y equal to 60, you have x is equal to 60 minus y. This is what you have here. Okay, x is equal to 60 minus y you have here. Now, why I write it as x is equal to 60 minus y instead of writing it as y equal to 60 minus x, just for the calculation pass. If I write it as y equal to 60 minus x, you will have it as 60 minus x the whole cube. So, either I will have to use a minus b the whole cube formula and then differentiate it, etc. here. So, for calculation sake, I just write x is equal to 60 minus y. If you want, you can write it this way also and proceed. Okay. So, p equal to xy cube, which is equal to 60 minus y into y cube. Now, you see, you can just multiply it and then differentiate it with respect to y. Okay. So, here if you are going to write it like this, you will have to differentiate it with respect to x here. So, both ways are applicable. You will get the same answer. Okay. So, here p is equal to 60 y cube minus y power 4 you get. So, differentiating it with respect to y, dp by dy is equal to, so when I differentiate y cube, you will get it as 3y squared. 60 into this is what, 180 y squared minus what will you get here, 4y cube. So, here your dp by dy is equal to 0, which implies your 180 y squared minus 4y cube is equal to 0 you get. So, y squared can be taken common here. You are left with 180 minus 4y equal to 0. So, what are the points you have here? Y equal to 0 and 180 minus 4y equal to 0. So, you will get 4y equal to 180. So, your y is equal to 45. So, there are 2 points here, the points whatever I have underlined, your critical points, but this is not possible. Why is it not possible? I cannot get my product to be equal to x into this one. If I take y equal to 0, it becomes 0. So, I cannot get an answer as 0. That is the reason we say that y equal to 0 is not possible, and therefore, this y equal to 45 only is the critical point in this case. Is it clear? Not that always y equal to 0 is not possible. In this case only we say that y equal to 45 is said to be the critical point. Now, we will apply the second derivative test. So, to apply the second derivative test, I will have to differentiate it again with respect to y. So, when you differentiate it, you will have it as 360y minus 12y squared. Okay. So, you have got the critical point. Substitute the critical point here, 360 into 45 minus 12 into 45 the whole squared. So, here when you multiply this, you will have it as 16,200 minus 12 into 2025. So, it is 16,200 minus 24,300, which is equal to minus 8,100. That is nothing but less than 0. Okay. So, if it is less than 0, obviously what can I say here? The product is said to be maximum. Okay. When, what is it here? Your y equal to 45, but they have asked us for all the two numbers. So, how do you find the other number x? By substituting in the relation there. What is it actually? X plus y equal to 60 you get. So, here your x plus what will I get here? 45 is equal to 60. So, what is your x equal to here? You will get it as equal to 15. So, what can I conclude here? The product is said to be maximum for the two numbers, x is equal to 15 and y is equal to 45. Your product here is nothing but xy cube. Okay, that is mentioned in the question. So, here as I told you earlier, the product is maximum at y is equal to 45. So, when y is equal to 45 you get, therefore, the required numbers are nothing but 15 and 45, or we say that the product is maximum for the numbers 15 and 45. Got it? Yes. Now, here the 15th question is also a similar one. Find two positive numbers x and y such that their sum is 35 and the product x squared y power 5 is said to be maximum. Okay, and their product. I'll have to find the two positive numbers x and y here. So we'll write the relation x plus y equal to 35. So here again we write it as x is equal to 35 minus y. If you want, you can write it as y equal to 35 minus x also. That also will give you the same answer. Okay. So here when I substitute it, what will I get? Your product is given as what? X squared y power 5. So it is 35 minus y the whole squared into y power 5 and then differentiating it with respect to y. So what will you get when you differentiate it with respect to y? dp by dy is equal to, okay, I'll have to use the uv formula in this case. Okay, otherwise I'll have to, what is it here, expanded by using a minus b the whole squared formula, then multiply it and then differentiate it. But here I am just applying the uv formula. So when I apply the uv formula, it's 35 minus, what is your uv formula here? If you want, I'll just write it here. U into v is equal to u into dv by dx plus v into du by dx. This is what you have here. So 35 minus y the whole squared into differentiation of this is what? 5y power 4 plus y power 5 into differentiation of this. What will you get here? 2 into 35 minus y into differentiation of 35 minus y. That's nothing but equal to minus 1. Got it? So here it is equal to 5 y power 4 into 35 minus y the whole squared you have here. 2 into minus 1 you will have it as minus 2 y power 5 into 35 minus y. This is what you have here. Got it? Now your dp by dy is equal to 0. So dp by dy is equal to 0 means what will you get? 5 y power 4 into 35 minus y the whole squared minus 2 y power 5 into 35 minus y equal to 0. I'll have to find the critical points. So to find the critical points, I'll have to equate the first derivative to 0 by the second derivative test. Okay. Now here if you see, I can take y power 4 common as well as I can take 135 minus y also common here. So I have taken that common. You are left with 5 into 35 minus y minus 2y equal to 0. Got it? So you are left with y power 4 into 35 minus 5, so minus y. So here when you multiply, you will have it as 175 minus 5y minus 2y is what you get here. So y power 4 into 35 minus y into minus 7y plus 175 is equal to 0. This is what you have here. So what's the value you get here? Your y is nothing but equal to 0. Your y is equal to 35. What is the next one you get here? Y is equal to 175 by 7. That's nothing but equal to 25. Now I'll have to see which are all the points, critical points possible in this case. When I take y is equal to 0, what will happen to your product here? P is equal to x squared into y power 5. The product becomes 0. That's not possible. Next is what? When you take y is equal to 35. Okay. So when you take y is equal to 35, what will happen to x here? X will be equal to 0 because what is the condition you get? X plus y is equal to 35 you get. So when I substitute it, you will get x is equal to 0. So that is also not possible here because when I substitute x is equal to 0, again the product becomes 0. So what happens here? These 2 points are not possible in this case. So what is the only critical point I have here? It's 25. So it's easy for me to verify also. So here I have written y equal to 35 and y equal to 0 is not possible. Therefore, y equal to 25 is the only critical point. Okay. Now finding the second derivative here, that is I'll have to differentiate the dp by dy. So to differentiate dp by dy, again I'll have to use the uv formula only there. So what will you get there actually here? It's nothing but 5y power 4 into a differentiation of this one, 35 minus y the whole squared. So you will get it as 2 into 35 minus y into differentiation of minus y. That's nothing but minus 1 plus 35 minus y the whole squared into differentiation of this will give you what? 20y cube. Got it? This is your differentiation of the first term plus the differentiation of the second term, but you have a minus sign there. So what is that you will get? It's minus 2y power 5 into differentiation of 35 minus y. What will you get? It's just minus 1 because differentiation of 35 will give you nothing but 0 minus of 35 minus y into differentiation of what is it here, 2y power 4, that's nothing but 10y power 4 is what you have here. Okay, so here I am not going to simplify it a lot because you are going to just substitute the values only here. So I'll just write it as minus 10y power 4 into 35 minus y plus 20y cube into 35 minus y the whole squared plus 2y power 5. Here again it's minus of 10y power 4 into 35 minus y you get. Now we know the critical point. I'll have to verify the second derivative test here. So we'll just substitute it. Minus 10 into 25 the whole power 4 plus 20 plus into 35 minus 25 is what, 10 plus 20 into 25 the whole cube into 35 minus 25 the whole squared plus 2 into 25 the whole power 5 minus 10 into 25 the whole power 4 into 35 minus 25 is nothing but 10. Now here if you see, your 25 the whole cube can be taken common because here everywhere you have got. So I have taken 25 the whole cube common. So you are left with 125 here. 10 into 10 is nothing but 100. So you have minus 2500. Here again this is gone out. This is what actually here, it's nothing but 10 the whole squared you will get. That's nothing but 100. 20 into 100 is nothing but equal to 100. Now here again 1 has gone out, 25 the whole cube. So you are left with 2 into 25 squared minus 100 into, what will I get here, 25. How do you get this 100? 10 into 10. Got it? So 25 the whole cube into minus 2500 plus 2000. 25 squared is nothing but 625 into 2, that's 1250 minus what will you get here, 2500. So here when I simplify it, you will get it as minus 5000 plus 3250. That's nothing but minus. My further simplification is not needed. I just want to check whether it is less than 0 or greater than 0. So don't go into the calculation depth. That is the reason I didn't simplify this much also here. Got it? So here whether it's greater than 0 or less than 0, that is enough. So here if you see, you've got a minus sign. So for sure this is less than 0. So if it is less than 0, what can you say? By the, what is it here, the second derivative test, I can say that the product is maximum at y is equal to 25. So at the, what's the other one you get? X is equal to 35 minus 25, that is equal to 10 you get. So what are the required numbers you get here? The required numbers are nothing but 10 and 25. So here always we make a mistake by stopping at this point actually here. So don't stop at that point because they have asked us the two positive numbers x and y. So you need to find out both x as well as y here. Got it? Yes. Now the 16th question here. What's the 16th one? Find two positive numbers whose sum is 16. Okay, so here if you see, find two, let it be x and y. So here sum is said to be 16 means one number will be what, x. So what will be the other number you get here? It's nothing but 16 minus x. And the sum of whose cubes is said to be minimum. So they have asked us the sum of these two cubes must be minimum. That is what they have asked us to check. So see how we can proceed here. Let one number be x. Let the other number be 16 minus x. So sum of the cubes. So I have just written it as yes. Okay, the sum here we write it as just yes is equal to, it's nothing but cube is what, x cube plus the other term. What's the other number you get? 16 minus x the whole cube. Okay, I'll have to find what is the two positive numbers where the sum is said to be minimum in this case. So again I'll be applying the second derivative test in this case. Differentiating it with respect to x, you have it as ds by x is equal to, what did you have there? It is x cube plus 16 minus x the whole cube. This is what you had here. So we have it as 3x squared plus 3 into 16 minus x the whole squared into differentiation of 16 minus x. What will you have it here? It's nothing but minus 1. So what rule we are using here? It's nothing but the chain rule. So here I can write as 3x squared minus 3 into 16 minus x the whole squared. So here I'll find out the second derivative also. D squared s by dx squared is equal to 6x. Here again it's what, 3 into 2 is nothing but 6 into 16 minus x into differentiation of 16 minus x is what, nothing but minus 1. So minus into minus is nothing but plus. So you're left with 6x plus 6 into 16 minus x. Now here your ds by dx is equal to 0. So what will you get? 3x squared minus 3 into 16 minus x the whole squared is equal to 0 you get. So 3 can be taken common. X squared minus of 16 minus x the whole squared is equal to 0. So here expand it, 3 into x squared a minus b the whole squared. What is 16 squared? 256. So it's minus 256 minus 32x. Minus of minus will give you what? Plus 32x plus x squared. Plus into minus is nothing but minus x squared. Okay. So here this x squared and minus x squared gets cancelled. You are left with minus 256 plus 32x is equal to 0. Okay, this 3 is not equal to 0 here. Now here your minus 256 is equal to minus 32x. So what's the value of x you get here? X is equal to 8. So you have got only one value here. Now what is your d squared s by dx squared is equal to? Substituting it here. So you have found out what is d squared by dx squared. That's nothing but 6x plus 6 into 16 minus x you get here. So it is 6 into 8 plus what will you get here? 6 into 8. So 48 plus 48 you get here. So that's equal to 96, which is greater than 0. So is the sum minimum? Yes. So when is the sum minimum here? The sum is said to be minimum when x is equal to 8 and what's the other number you get here? Y is equal to 16 minus 8. That's nothing but equal to 8 itself. You understood? So here till now the questions, 3 or 4 questions whatever I have done, they were in the same pattern. Only thing is what either it was product was different, but here the last one what I did was the sum of the cubes it was asked actually here. Okay, so from the 17th one it's going to be a little different one here. Okay, so here we'll have to find out where the area of a square or whatever it is. Okay, such type of problems you're going to see from the 17th question. So it's very, very important. It's a compulsory 6-mark question from this exercise 6.5 actually, and mainly the 6-mark questions it will be asked only from the 17th question as well as the miscellaneous questions. Miscellaneous questions also I will be doing it in the next video there, but here if you see in this case from these questions onwards all the questions are very, very important compulsory 6-mark question. Okay, and it's one type of thing where you can also boost up your marks. Okay, that also is there. So here I'll just read the question here. A square piece of tin of side 18 centimeter. So there is a square piece of tin 18 centimeter you have here. It is to be made into a box without a top. So it is to be made into a box without a top by cutting the edges of the square, by cutting of the square from each corner. Okay, so they are going to cut it like this and folding up the flaps to form the box. So they are folding up the flaps to form the box. What should be the side of the square to be cut off so that the volume of the box is the maximum possible? So what should be the square which is cut off? Okay, so here if you see, if the side of the square is not, if the side of the square is nothing but 18 centimeter I have here. Now here if you see this portion is cut off, this portion I take it as x here, here also I just take it as x. Okay, so x means now what will be the distance of this one? Okay, this whatever this cut off portion. So what will I get here? It is 18, this portion goes off and this portion also goes off. So x plus x is what? 2x. So what will I get here? 18 minus 2x. So similarly this portion also will be what? 18 minus 2x. Here also it will be 18 minus 2x. Here also if you see it will be 18 minus 2x. You understood in this case actually here? Now here what should be the side of the square to be cut off so that the volume of the box is said to be maximum as possible. So what is the volume of the box which has to be maximum as possible? This is what I'll have to find out. So you know what is the volume of that box here. So we'll see that. Here as I explained, you just take a square piece of paper here and you imagine this is nothing but 18 here. This is also 18 centimeter, this is also 18 centimeter. So here if you see I have cut the corners. So the corners whatever I have cut in this case I will take it as x and x here. So this also is nothing but x and x. Here also if you see I have taken it as x and x in this case. Here also this is nothing but x and x. So when I cut like that, what happens actually here? This edge if you see here it is reduced to this minus this. So what will I have here? It's nothing but 18 minus 2x. This is what you have. Similarly this edge also will be reduced to 18 minus 2x. So what will be the length and breadth here? It will be nothing but 18 minus 2x and 18 minus 2x. So what will happen actually here? You will get a box like this. This is how you fold the flap actually here. Now when you fold the flap, what will be the height of this box? If you see the height of this box, what is that I have written here? It's nothing but x. Okay, so here if you see, this will be nothing but the height. So here wherever I fold here, this will be the height of the box. So what is the height of the box you get here? H will be equal to x. So L is equal to this, your breadth is equal to this, and your height is nothing but equal to x here. So just imagine a box where you get your dress covers and all, no boxes and all. Actually here it's just a small carton box here. So you have the length, breadth, as well as what is that actually? It's nothing but x. So it's only going to be an open box. I hope you are clear with this concept. Now we'll go over to our problem here. Okay. So here by now I have written here your length is equal to 18 minus 2x. Your breadth is equal to 18 minus 2x you have here, and your height is equal to x. So here I have drawn the figure here. This one it's nothing but an approximate one. How you cut it, no, that one. Now you know they've asked us to check whether the volume is said to be. What is the question? We'll just read it once again here. The volume of the box is maximum as possible. That is what is asked here. So here I'll write what is the volume here. What is your volume equal to? Volume of a box here. Length into breadth into height. Okay, volume of a rectangular box, length into breadth into height. So your length is nothing but 18 minus 2x, your breadth is nothing but 18 minus 2x into x. So you have it as 18 minus 2x the whole squared into x. This is what you have here. So by the second derivative test, we'll differentiate it with respect to x. I'll be using the uv formula. So when I use the uv formula, what will I have? 18 minus 2x the whole squared into differentiation of x. What is differentiation of x? That's nothing but 1 plus x into differentiation of this one. What is differentiation of this? It is 2 into 18 minus 2x into differentiation of 18 minus 2x is what it is equal to minus 2. You understood? Now 18 minus 2x can be taken common here. So it's 18 minus 2x into 18 minus 2x. So here if you see, you are left with what actually here? 2x. And here again you have, in this case, what is that you have here? It's nothing but minus 2. This is what you have here. Got it? So you are left with what actually here? Minus 4x you have here. So it is 18 minus 2x into 18 minus 6x. So here when I write dv by dx is equal to 0, you will get 18 minus 2x into 18 minus 6x is equal to 0. So what's the value of x equal to here? X is equal to 9 and x is equal to 3. Okay. Now x equal to, since it's a length and breadth of that box there, you have x9 and x is equal to 3 you get. So when I put x is equal to 9, what will happen to the length there? It is 18 minus 2 into 9. That's nothing but equal to 0. Is it possible here? No, it's not possible for us to have. Similarly, the breadth also will be equal to 0. So if I get volume will be equal to 0, so that's not possible. So what do I say here? This x equal to 9 is not possible. So which is the other one which is possible here? X is equal to 3. Got it? Okay, so here x is equal to 3 only is the critical point. Now we'll find out the second derivative, d squared y by d squared v by dx squared. So again apply the uv formula here. 18 minus 2x into differentiation of this will give you what? Minus 6 plus 18 minus 6x into differentiation of this will give you nothing but minus 2. Now here at x is equal to 3, d squared by v by dx squared at x is equal to 3 is what? You will have it as 18 minus 6 into minus 6 plus 18 minus 8 into minus 2. So here in this case what will I get here? It's equal to minus 72 is what you have here, because 12 into minus 6 is nothing but minus 72. This becomes nothing but 0. So what can I say here? The volume is said to be maximum when x is said to be equal to 3 here. Okay, because they have asked us the dimension. So I can say that the volume is maximum when x is equal to 3. Got it? Yes. The 18th question. So it's similar to the previous one. What's the difference between that and this is? There it was a square box which was cut and then made it into a open box. Here it's nothing but a rectangular box. The same way it is cut at the corners, and what is that they do actually here? They form a rectangular open box here. So that is what is given here. A rectangular sheet of 10, 45 centimeter and 18 centimeter. Okay, is to be made into a box without a top by cutting off the square from each corner and folding up the flaps. Okay, so it's 24 centimeter here cutting off the square from each corner and then folding up the flaps, just like how I did, no? You cut off the corner there and you fold up the flaps. What should be the side of the square to be cut off so that the volume of the box is said to be maximum? So again, what should be the side of the square? Your side of the square, what is that you have taken here? It's nothing but x here. I'll have to find out what should be the side of the square to be cut off, because this is cut off in the form of a square, and then this is the flap we have here. As I told you, no, this is the flap we have here. So what is the portion which is cut off so that your volume is said to be maximum? That is what is asked here. Okay, here I have taken a square piece of paper. Here the same example with a rectangular piece of paper, they have it here. Got it? So here I have drawn an approximate figure here. So this is the figure. The length is 45 centimeter and the breadth is 24 centimeter. So now we will write what is the length here. You know, it is equal to length of this portion is what I need here, because I am going to find out the volume of the box and not this one here, the rectangular sheet. Okay. So here the volume for this, the length will be nothing but 45 minus this part is nothing but x minus this region, that's nothing but equal to minus x. So what will I have here? It's 45 minus 2x. This is what you get here. So it is 45 minus 2x is what you have here. Same way here also you will get it as 25 minus 2x. The same concept you have it here also. So what is the height here? The height is nothing but this folded portion, whatever you get, that's nothing but your x. Your height is equal to x. Now you know what is the volume of the rectangular box here? Length into breadth into height. 45 minus 2x into 24 minus 2x into x. So it is 45 minus 2x into 24x minus 2x squared. This is what you have here. Okay. Now differentiating it with respect to x, your dv by dx is equal to, what is that I'll have to do here? I'll have to apply the uv formula. So when you apply the uv formula, what will you get? It's 45 minus 2x into differentiation of this. What is that? It's 24 minus 4x plus 24x minus 2x squared into differentiation of this. What will you get? 0 minus 2x, that's nothing but minus 2. Okay. So we'll just multiply it. 45 into 24 is nothing but 1080 minus 180x minus 48x plus 8x squared plus minus 48x, and here if you see you will get it as plus 4x squared. Okay. So here I have just rewritten it as, what will you get in this case? It is 8x squared plus 4x squared minus 48 will give you minus 96 minus 180x plus 1080. So what will you get here? 12x squared minus 276x plus 1080. Now we will find the critical points here. So when I find the critical points, what will you get? dv by dx is equal to 12x squared minus 276 plus 1080 is equal to 0. Now we'll just divide it by 12 here. So when I divide it by 12, what will you get? X squared minus 23x plus 90 equal to 0. So here minus 23, I can write it as minus 18 and minus 5. So it becomes x minus 18 into x minus 5 equal to 0. So you have x is equal to 18 and x is equal to 5. So here I say that x equal to 18 is not possible. What is the reason? You take 24 minus 2x, the breadth. Okay, so when I take 24 minus 2x, what will I get? 24 minus 2 into 18. You will have it as 24 minus 36. What is 24 minus 36? It's equal to minus 12. Now, can I take the breadth of the rectangle to be minus 12? It's not possible here. That is the reason I say that x equal to 18 is not possible. When I take for 45 minus 2x, I will not have a problem. But for the breadth, I will have a problem. So I cannot take this value. But this value, I can have it for both. Okay. So this is not possible. But I can take only x is equal to 5. I hope you understood why I say that x equal to 18 is not possible. You will have to be careful at that point also. Blindly don't just take both as the critical points. Okay. So here you have x is equal to 5 is possible. Now we will just substitute the second derivative here. D squared b by dx squared is equal to 24x minus 276. So here 24 into 5 minus 276, it's 120 minus 276. So I already told you the value is not important, whether it is positive or negative only is important here. So it is less than 0. Therefore, what is the volume of the box here when it is said to be maximum at x is equal to 5. You understood? So first one what we saw was a square one. Second one the same thing we have seen for a rectangle. Okay, you can expect any type of questions with different dimensions. Okay. Now the 19th one, another important one question here. Show that all the rectangles inscribed in a given fixed circle, the square has the maximum area. Okay, so here show that the rectangles inscribed in a given fixed circle. So you have a circle. So here in this case a rectangle is said to be inscribed. What they say here is, they say that the square has the maximum area. This is what they have asked us to check in this case. So here I'll just take the length and breadth of the rectangle here. So you will have it as x here. This will be nothing but y. Okay, the length and breadth of the rectangle. So what is the length of the rectangle here? You will get it as 2x. Breadth of the rectangle I have taken it to be equal to 2y. This is what I have here. Breadth is taken as 2x and 2y in this case, because I am going to take half of it. That's why I take it as 2x and 2y in this case. Now here if you see, I'll have to find out that the square has got the maximum area. So what are the rules for square actually? Or a square, if you see, length and breadth must be equal. So here when I solve, I must get my x to be equal to y. Only then I can say that the, what is it here, inside a rectangle, sorry, inside a circle, the square has got the maximum area. So we'll see how we can find out. So I have drawn a circle here. Okay, a rectangle in this case you have here. So this is your x and this is nothing but your y I have taken in this case. Now here if I have taken the you have a center of the circle, you know this will be nothing but the height here. Okay, it will be nothing but half of that, it's y. Similarly half of 2x is nothing but x. This is nothing but your radius of the circle. So I have taken this triangle OAE or AOE, whatever it is. So here if you say it's a right angle triangle, I can apply the Pythagoras theorem here. So when I apply the theorem, hypotenuse square r squared is equal to x squared plus y squared, you get here. Got it? So here in this case your y squared is equal to r squared minus x squared. So what is your y equal to here? Square root of r minus x squared. So always I convert it and keep it, because here if I have it in terms of x and y, it's not possible for me to apply the second derivative test. That's the reason always I reduce it to one variable here. Now the area of the rectangle, because what is mentioned in the question, the area, it has got the maximum area. So I need to find out the area of the rectangle. What is the area of the rectangle here? It's length into breadth. So if it is length into breadth, it's 2x into 2y. Okay, that is what you have here. So 2x into 2y, I will write it as 4xy, you get here. You know what is your y equal to? Y is equal to square root of r squared minus x squared. So you have got your function. Now it's easy for me to check whether it has got a maximum area or not. That is, the maximum area which can be inscribed in a circle is said to be a real square. Okay, this is what I'll have to prove here. So here I have just taken this r to be equal to a in this case, and I have written it as x into square root of a squared minus x squared. Okay, so we'll differentiate it. Your dA by dx is equal to 4 into u into v. What will you get? X into 1 by 2 into a squared minus x squared, the whole power minus 1 by 2 into differentiation of a squared minus x squared will give you what? Minus 2x plus square root of a squared minus x squared into differentiation of x, that's nothing but equal to 1. So this is the UV formula. Okay, this is what you have here. Here I have applied the chain rule. So we'll simplify it here. This 2 and 2, it gets cancelled. So you are left with 4 into minus x squared divided by square root of a squared minus x squared you have here. Okay, because it is a squared minus x squared, the whole power minus 1 by 2 plus square root of a squared minus x squared. Now it is 4 into, cross multiplying it here, you will have it as minus x squared plus this, when you cross multiply, it's a squared minus x squared divided by square root of a squared minus x squared, which is equal to 4 into, here again it's a squared minus 2x squared divided by square root of a squared minus x squared. Now I just equate it to 0. dA by dx is equal to 0, you get here. So you will have it as 4 into a squared minus x squared divided by root of a squared minus x squared is equal to 0. When you cross multiply, it is a squared minus 2x squared is equal to 0, you get a squared is equal to 2x squared. So you will get x squared is equal to a squared by 2. X is equal to plus or minus a root by 2. I cannot have x is equal to minus a by root 2. The reason, the length cannot be measured in negative, so this is not possible. I will take only x is equal to a by root 2. You understood? Okay. Now the first step is over here. I'll have to find out the second step, that is the second derivative. You know what is your dA by dx. What is your dA by dx equal to 4 into a squared minus 2x squared divided by square root of a squared minus x squared. So to differentiate it again, I'll have to use the u by v formula. So when I use the u by v formula, d square a by dx squared is equal to 4 into v into square root of a squared minus x squared into differentiation of the numerator is what? Minus 4x minus this u into a squared minus 2x squared into differentiation of the denominator is what? 1 by 2 into a squared minus x squared the whole power minus 2 into differentiation of this will give you what? Minus 2x divided by square root the whole squared. What will I get? A squared minus x squared. You understood here? So we'll just simplify it a little here. 4 into minus 4x into square root of a squared minus x squared. Here if you see your 2 and 2 it gets cancelled. Here you have an x here. X into a squared minus 2x squared. This comes to the denominator. So you have written it as square root of a squared minus x squared divided by a squared minus x squared. So it is 4 into cross multiplying it here minus 4x into a squared minus x squared plus x into a squared minus 2x squared divided by a squared minus x squared into square root of a squared minus x squared. Got it? So here when I multiply it, you will have it as minus 4a squared x plus 4x cube plus xa squared minus 2x cube divided by the denominator. So here it's equal to 4 into minus 3a squared x plus 2x cube divided by a squared minus x squared into square root of a squared minus x squared. Now we'll just substitute the critical point here. When I substitute the critical point, what will I get? 4 into minus 3a squared into a by root 2 plus 2 into a by root 2 the whole cube divided by a squared minus a. Okay, so here this is what you get here. I've just substituted it here. So you will get it as 3 minus 3a cube by root 2 plus 2a cube by 2 root 2. Of course, when you subtract the numerator itself, for sure it will be negative, because when you take the LCM, what will you get? You will have it as 2 root 2. So you will have it as minus 6a cube plus 2a cube you will get. That's nothing but minus 4a cube. So that's nothing but less than 0. Already I told you the exact value is not needed. It's enough if you check whether it is said to be positive or negative. Okay, so here that's why I say that it is said to be less than 0. I have not done the simplification part after this. Okay, so if it is less than 0, what can I say here? It is said to be maximum by second derivative test. So what can I write here? Thus your a is said to be maximum when x is equal to a by root 2. Now they have asked us to show that the maximum area is said to be a square is what they have asked us to mention. So only if I find out the value of y, I will know whether it is said to be a square. Okay, so we'll find out y. You know what is your y equal to? Y is equal to what? Square root of a squared minus x squared. That is, in the beginning I would have written it as r squared minus x squared. I told you after that I am taking the r as a here. Therefore, I have written it as a squared minus x squared, square root of a squared minus a squared by 2, which is equal to square root of a squared by 2. So that is also nothing but equal to a by root 2. So what happens here? Your x is also a by root 2, your y is also a by root 2. So what happens actually here? Okay, so whatever is inscribed in the circle, the maximum area which is inscribed in a circle is nothing but a square. Okay, so here, okay, so the maximum area, okay, so here I'll just write it as the maximum area which is inscribed inside a square, inside a circle is nothing but a square. Otherwise, what can I say here? That rectangle, whatever I have taken inside the square, sorry, inside the circle is nothing but a square. You understood here? So again, it's a very important one. Hence, the area is maximum, and here you will have to find out this. Again, I am telling you here, don't stop till this step by just saying that it is maximum. That is not the question for us here. I'll have to show that the rectangle, whatever is inscribed inside the circle is nothing but a square. This is what I'll have to show. Okay, so I need to show this point. Only then your answer is complete here. Got it? Yes. Now here, your second question. So what is, sorry, your 20th question. show that the closed right circular cylinder of a given surface and maximum volume is such that its height is equal to the diameter of the base. Okay, its height is equal to the diameter of the base. So what is it actually here? You have a right circular cylinder. Okay, so this is what you have, the right circular cylinder of a given surface and the maximum volume. So I'll have to find out what is the volume. So you know, for a cylinder what all you have actually here, such that its height is equal to the diameter of the base. I'll have to show either your h is equal to d, otherwise I'll have to show that h is equal to twice the radius. Twice the radius is also nothing but the diameter of the base, because this is a circle, this is also a circle. You all know how to find out in this case. Okay, so here we'll see how we can find out. Here you have the given surface and maximum volume. So what is it? I'll have the surface area as well as the maximum volume. So see, we'll see how we can proceed with this. So this is a right circular cylinder. This is the height of the cylinder. So the base of this I have taken it to be equal to r. This is what we have taken here. Now the surface area of the cylinder, you know, this is the formula, 2 pi RH plus 2 pi r squared, because that's also mentioned here. So I need to find out what is the height alone here, because you know what is the volume of the cylinder. Volume of the cylinder is equal to pi r squared h. By keeping r as a variable and h also a variable, I cannot differentiate it with respect to both. So either I'll have to bring it in terms of r or in terms of h I'll have to bring it. So I'm going to bring it in terms of r here. Therefore I'm going to rewrite it as, taking it to the other side, s minus 2 pi r squared is equal to 2 pi r h. So your h is equal to s minus 2 pi r squared divided by 2 pi r. Got it? Now volume of the cylinder is what? Pi r squared h. Substituting your h here, pi r squared into s minus 2 pi r squared divided by 2 pi r. Now I'll just multiply and split it as two separate fractions here. S pi r squared divided by 2 pi r minus 2 pi r squared into pi r squared divided by pi r, 2 pi r you get. So what happens here? Your pi and pi gets cancelled, r and r also gets cancelled. So you're left with s by 2r minus your 2 pi and 2 pi and 1r and 1r. R into r squared is what? R cube. So it's minus pi r cube. Okay. So this is the function. I'm going to differentiate it with respect to r, because what is the variable you have here? We have got it as r. So differentiating it with respect to r. What is your dv by dr equal to? S by 2 minus 3 pi r squared. So what is your dv by dr equal to 0? When I find the critical points, it is s by 2 minus 3 pi r squared is equal to 0. So here you get s is equal to 6 pi r squared. Have this in mind. I'll be using it later. You will have r squared is equal to s by 6 pi, because I need the value of r. Okay. Now your second derivative, d squared y by d by dr squared is what? Differentiating this, it will be nothing but 0. Here you will have it as minus 6 pi r when you differentiate it. Got it? So here, when I substitute it, I'll have to check whether it is less than 0 or greater than 0. D squared v by dr squared at r is equal to root of s by 6 pi is what actually here, because why I write as root of 6 pi? You know that your r squared is equal to s by 6 pi. So I need only r. When I substitute it, minus 6 pi into root of s by 6 pi, for sure it is less than 0. So what can I say here? I say that the volume is said to be maximum here. Okay, the volume is said to be maximum, but that is not really the condition asked. They have asked us to show the volume is maximum when the height is equal to the diameter of the base. So I need to find out the height also. I told you, keep this in mind. I told you in the in between. Okay, so s is equal to. So when I started with, we had a relation h is equal to s minus 2 pi r squared divided by 2 pi r. By now we got s is equal to 6 pi r squared. So what do you get here? 6 pi r squared minus 2 pi r squared divided by 2 pi r is what? 4 pi r squared divided by 2 pi r you get there. So what is the answer you get here? It is equal to 2r. What is this twice of the radius? It's nothing but the diameter of the base. So have you got your h to be equal to the diameter of the base? Thus the volume is maximum when the height is twice the radius, or what will I write here actually here? The diameter of the base. This is what you have here. Okay, it is said to be the diameter of the base.